Hi, good morning everyone. My name is Linda, and today I'm going to share my project, Cognitive Load in Map-Based Tasks Using Eye Tracking Data. In the next 10 minutes, I will walk you through how I understood the paper, how I cleaned the dataset, and finally how I analyzed the data to answer the research question. To give you a quick overview, my presentation will go with 3 parts. First, understanding the paper. Second, cleaning the eye tracking data in Google Colab. And third, analyzing the data using statistical methods. With this structure in mind, let's move on. First, I began by understanding the paper and the context behind the experiment. This step was essential because interpreting eye tracking data requires knowing how tasks were designed, how raw data was named, and how the research questions were formed. Here, I checked the meaning and naming of each column in the raw CSV files and also checked with the README file. There were 20 participants, but one participant, P10, was excluded. In addition, 3 participants' data were split into multiple files, so they needed to be merged later. Understanding this structure helped me prepare for cleaning process. Then, the main research questions of this study is, how do map type and task type interact to influence users' cognitive load? The tasks include 2 location finding tasks and 1 route planning task. Now that we understand the setup, let's move on the data cleaning. Since eye tracking data is often messy and contains noises, this step was one of the most time-consuming parts of the project. In total, I performed 17 cleaning steps in Google Colab. I will highlight only the most crucial steps to share with you guys. Like first one, I filtered each CSV files to keep the only required column that related to cognitive load. And I removed the row with poor eye tracking validity. This is so important. We don't need to add any bad data in our dataset. So I removed the values of 3 or 4 for the validity. Yes, so continuing, I also check with the unrelated columns I don't need. I remove the timestamps and also keep the unique rows. I also remove the rules where the fixation index was missing, but I can still know that number, just remove it to keep the data clean. These steps ensure that only high quality data remained. Continuing, I calculate the fixation count and total fixation direction per stimulus. I rounded the fixation direction to 2 decimals. And I add the participant column back to the file name so I can easily to recognize it before I merge all the files together. Now, these transformations make the dataset consistent and ready for merging. Finally, I combined all process fixation files into one dataset. I separate stimuli into map and text type because originally it wrote it at F1 as camp T1. There's like 3 information in one column. I separate it. Then I ran to a 2-way repeated measures ANOVA. I created a bar plot, box plots, and visual comparisons for fixation measures. With the data fully cleaned, I'll then move to analyze. My goal was to determine whether map types, text types, or their interaction had an effect on cognitive load. I conducted a 2 × 3 repeated measures in ANOVA with map type, cartographic versus satellite. Task types T1, T2, T3, dependent variables, fixation direction, fixation count, and let's look at each result in more details. First, the main effect of map was not statistically significant. This means the type of map, cartographic or satellite, did not significantly influence total fixation direction. So, map design alone did not create noticeable difference in cognitive load. Next, task type had a marginal effect on fixation direction. Before correction, the p-value was 0.047, but after applying the greenhouse gas correction, it increased to 0.057, slightly above 0.05. Thus, task type might influence direction, but it was not statistically strong. The interaction between map and task types was not significant either. That indicates that the effects to tasks did not change depending on which map was used. For fixation counts, the pattern was similar except for one key finding. Map type still not significant. Task type significant. Different tasks lead to different numbers of fixations. Interactions not significant. This shows that task difficulty plays a stronger role in driving eye movement activity than map type does. To better understanding the result, I also visualize the mean and median fixation direction and fixation count across task and map types. These plots help confirm the statistical results and also revealed a few outliers. I identified two notable outliers, for example, in T1 CMAP and T2 SMAP. However, these outliers did not substantially affect overall statistical outcomes, which was great. To our conclusion here are the answers to our research questions. First, will map type effect? There was no significant effect to map types on cognitive load. About the task type effects, task type significantly influence fixation count, indicated differences in cognitive demand. Fixation direction shows a marginal but not significant trend. And the last one, interaction effect. No interaction effect was found. This influence of the task of cognitive load was similar across both map types. So, overall, task complexity matters more than the map designed in this experiment. Thank you for your listening, and I'm happy to answer any questions.